Okay, today we're going to talk about how to use a scientific calculator to do very common pH problems, and it's not going to take very long. The model that I'm using today is for the Texas Instruments TI-30X2S, but there are no doubt other calculators that have approximately the same layout. Just check first before you follow along. Okay, the first thing we're going to do is to look at how to convert just regular decimal form writing on the calculator to scientific notation, and it's actually pretty easy. So you see we have this number here, 2,340, and if we want to convert it to scientific notation, there's just a couple of buttons we have to remember. First of all, the second function, and then the button right beside it, where above it says SCI/ENG. This is the button we ultimately use. All right, so if you hit the second function button, you will see precisely 0 happening. But if after that you hit the button next to it, you can see the menu that's pulled up between floating decimal and scientific notation. So all you have to do is hit those little arrow keys to make it go whichever way that you want it to go. Of course, in this case, we're going to flip it right over to scientific notation. And then when we hit equals, we will no longer have it in decimal form. We'll have it in scientific notation. 2.34 times 10 to the third. And one quick but necessary thing that we need to get out of the way is how you actually enter scientific notation from scratch. Say something like 9.48 times 10 to the 12th. That's no special number, that's just something I pulled out of the air. But anyway, we need to know how to enter that. When we're entering problems, we can put them directly into the calculator. So 9.48, and then you don't touch the multiply key. You don't touch anything other than this second function. And then right above the 7 key, there's this double E that is above the key itself. And that's going to handle putting it into scientific notation for you. So then after that, all we have to do is enter the exponent. Enter 12. And then when you hit equal, you'll see what the calculator spits back out. This is the form the calculator writes scientific notation in. So again, you don't touch the multiplication key. You just hit that double E, and that puts it into the scientific notation form for you. There'll be a couple of other examples that we're going to see as we go along. All right, so our first real problem would be something like this. And these are probably the most common type of problems in looking at acids and bases. What is the pH of an aqueous solution with hydrogen ion concentration of 2.6 times 10 to the negative 6? So the equation you will need, and the equation you will virtually always in any type of standardized tests for chemistry need to have memorized, is that the pH is the negative log of the hydrogen ion concentration. And of course, the question is, how do you enter that into the calculator? You're going to want to end up entering in this form, but obviously it's not quite as direct calculator entry as we might think, as we just saw in the previous example. One big question is whether or not to use the key that I have circled here, or another key that looks very similar, and it's among the most common calculator entry errors that we have. So people are very often wanting to use this key just right off the bat, the very first key they touch, and it turns out to be exactly the wrong key. But if we hit the bottom key instead, the one right below the 3, you'll notice up on the screen there's a little minus sign that's popped up. And then all we have to do is hit the log button. We don't have to hit the second function for anything. And then just type in the scientific notation, 2.6. And then remember second function, double E key, and then just type in the exponent. In this case, the exponent's negative, so negative 6, close parenthesis, hit equal, and then that's going to give you the answer. The answer for this problem is, the calculator says 5.58. We're going to need to round it to 5.59 given the other digits. But that's it. It's as simple as it can be. Just the negative log of the hydrogen ion concentration. All right, for another one, another really common type of problem, says the pH of an aqueous solution is 6.87. What is the hydrogen ion concentration of the solution? So in other words, this time they've given you the pH. And you use the same type of equation, but just rearranged slightly. All right. So it would be more commonly written like this: the hydrogen ion concentration is equal to 10 raised to the negative pH power. So in this case, we want to take, since we're going to be entering negative 6.87. Second function, and then if you see right here, 10 raised to a power right above the log key, negative, and then just add in the pH, 6.87, close the parenthesis, and then hit equal, and it will give you the answer 1.34 times 10 to the negative 7, which we're rounding a little bit differently down here. Right. And one last type of problem that's very common we want to look at is based on a concept of something called the ion product constant for water. And the idea is that if you have any aqueous solution, no matter what the pH is, very, very acid or very, very alkaline, the product of the hydrogen ion concentration and the hydroxide ion concentration is always going to be 1 times 10 to the negative 14th. Always. So that way, if they give you one or the other, the hydrogen ion concentration or the hydroxide ion concentration, you can always calculate the other one. For example, if we solve this for the hydroxide ion concentration, all we need is K sub W over the hydrogen ion concentration. If we solve it for the hydrogen ion concentration, we solve it that way. It's pretty simple. All we're doing is just dividing one side by either the hydrogen ion or the hydroxide ion concentration and solving it down here. Here we have solved for hydroxide ion concentration by dividing the hydrogen ion concentration on both sides. Anyway. All right, so a problem that's based on this would be something to the effect of, what is the hydrogen ion concentration of a solution if the hydroxide ion concentration is 3.7 times 10 to the negative 11th? All right, so here is the formula for the ion product constant for water. And here is this rearranged so that we are going to solve for our hydrogen ion concentration. We already know what the ion product constant for water is. They've given us the hydroxide ion concentration, so all we have to do is divide one by the other. So this might be a little bit of a challenge to enter into the calculator if you're not familiar with it, and we can just do it like this. We say 1, and we don't have to say the 0.0 part, but 1 second function, double E, negative 14, and then divided by 3.7, second function, double E, and then add in the negative 11. And then we just hit equal button, and we get our answer of 2.7 times 10 to the negative 4th. All right, so I tried to do a few each of very common type of either problems or calculator entry issues. And so this is really just hitting the very tip top of it, but it's enough to go with basics. And that is it.